Hello friends, so welcome in the new video. So this is the continuation part of the GSM interface, and this time I'm going to interface GSM model with STM32, and this time it will be more complex because we are not using Arduino, so we don't have inbuilt libraries. So this time we have to implement each and everything using the code, and this will be the connections. You can see the board or STM32 board is connected with the GSM via the UART. So in UART, we all know that two wires are there. One is TX and one is RX. And second is two wires are for power supply and ground. So this will be the connections. And process will be same, right? After connecting this, you can either send SMS or you can either receive SMS by passing or this command. So first of all, we will pass this command for configuration, and then we will do whatever activity we want to do. So in this first part, I will configure this in this receiver mode for receiving message, and then from external side from another mobile, I will simply send some messages, and we will try to control LED, means we will blink LED. When I will send on message, LED should on, and when I will send off message, LED should off. Okay, so the purpose of doing this exercise is you can implement any type of application using this type of base code. So I'll provide you the code also in the description, so you can use this code in your application and you can build whatever you want to develop, right? So for that, I have this board selected, and I will simply configure first of all UART. And one more thing I will have to tell you, that this time we will use two UART. So one UART is with our board, which our board connected with, and second UART is this, our internal onboard UART, right? Onboard UART means what? Because between the STM and this GSM, some communication will be there, right? Some communication established, like this board sends something to this GSM, this GSM will send something to this board, but we cannot see it, right? Because we do not have any other uh, interface to display this, because we don't have LCD or, but we have this onboard UART. So in this video, I will configure two UART instead of single, one to communicate with the GSM and one to communicate with this wire. So on our computer in this real term, we can observe this, right? This will be simply for the testing or for the displaying purpose. Means we can know that what is happening right inside the board. So now it is taking time. So first of all, we have to configure these pins and then we will write a code. It is taking time, so we have to wait. And now I think this process is completed. So first of all, we have to simply clear all the pins, right? And then we have to select the crystal. Okay. Now, as I told you earlier, we will going to use two UART. So first will be the UART 5, and with this UART 5 only our board is connected with, right? And this is connected with pin number. Let me show you the diagram with this pin, right? PB8 and PB9. So this is for UART 5. So let us check with UART 5 which pins by default selected, PB12 and PB13, but I have to change it from this PB to PB8, PB9, right? So let us change it. Since these are multiplex pin, so you can change the position, right? So this is UART RX and this is UART TX. One more thing, To control the LED, we have onboard LED connected with PB7. So I will simply configure this as a GPU output. Right? And one more thing, as we know that we need one extra UART to display message on our PC, we will going to use UART3. Okay, so this is onboard UART. I've used this in my many previous videos, and this will also select some by default pin. You can see it selects PB10 and PB11, but our onboard UART is with PD8, PD9. Let me show you. Just search UART 3. This is our onboard user, right? And you can see the pin PD8 and PD9. So you have to select this PD8 and PD9. Then and then you will observe this on terminal. It could be real term or it could be any other Terra term, right? User TX3, EX and RX. Now with this, to receive the SMS, I will not use any polling mode, but instead of that, I will use interrupt. So for that, you have to simply select this NVIC and enable this UART5 global interrupt. Okay, because our UART5 is connected with this board, and whatever activity happening over here, right? This board will not continuously wait for this message, but rather than waiting this message, waiting for the message, it will simply enable the UART interrupt, and whenever something is receiving, interrupt will trigger and we will capture that letter. Right? We will simply configure interrupt for single letter only, right? And if you have a large message, then the interrupt will trigger that many times, and ultimately we will have whole message with us, right? So this will be the uh, method how we will going to receive the message. Now all configuration done. Now let us generate the code simply. And method is same. Okay, so I will simply use these commands. At plus cmgf is equal to 1, at plus cnmi is equal to 12000, and then module will configure and module will wait for the SMS, and whatever message module will receive, it will simply forward it to the board, right? So now we have this default code, and since we are using UART, so I will open UART file so that we can directly take the code from this UART.c, right? So first of all, uh, okay, this is the main function. So first of all, what I will do, I will simply write two functions, because here we have to send many messages on UART5 and many messages on UART3. So instead of writing this uh, all the time, let us define two functions, and I will simply pass whatever string I want to send on UART, and this function will handle all this. So let us define one function, send command on UART3. Okay, and I will simply pass argument cmd, and here we will simply write line to send this cmd on UART. Okay, so for that we have some inbuilt function, you can see. So I can simply search using this, right? You can see we have UART transmit, and I will simply copy this function as it is and paste it over here. Now I have to simply change this argument. So since this is about UART3, I will use UART3's handler, right? and you all know that here you have to write UART3, okay, and here command CMD, sorry. So we will use this typecasting, and instead of P data, this time I will use CMD because our message should pass on UART3, right? Here size of the command. So let us say strlen length of this CMD, whatever command you will pass, and this is simple timeout. So I can select any random value. Let us select 1000. If required, we will going to change it in future, right? During this experiment only. Now, same function we will write for UART5. Okay, with UART5 our GSM module is connected, and you have to change this handler only, right? Other things will remain same. Now let us start this configuration part. So using this UART5, I will start. So first of all, first command will be at/r/n, right? So this will be the first command. So automatically this command will forward these two UART5, and with your UART5 GSM module is connected. So this command ultimately forwarded to GSM module. Now let us add some delay. So after each command, we will add some very small delay, and I have to now send two more command. I'm just copying this. Now next command is 80 plus CMGF is equal to 1. And second command is 80 plus CNMI is equal to 12000. Okay. So now configuration part is done. Okay. Configuration part is finished. Now after configuration part completed, let us send some indication on UART3 so that user can come to know that okay, configuration part is finished. GSM configuration done. Okay, so now configuration part is done. Now as I told you earlier that we will going to use interrupt based communication. So I will not use this simple receive, but I will use receive it function. So it for interrupt, right? So now let us copy this, and after configuration part we have to simply call this function, so it will enable this interrupt. And next time if any character or any some activity will receive on this UART5, it will automatically trigger the interrupt. Okay. So our UART5 handler of UART5, and as I told you earlier that we will going to receive only single byte, you can say. Okay, we will not wait for whole message, we will receive single byte multiple time. Okay, so here I'm giving size 1, and to receive the message I have to declare one more character. So let us give the name like you are here, right? And I have to declare this, right? So now this will enable the interrupt. Okay, this will enable the interrupt, and I have to write callback function now. Okay, because in interrupt it will automatically call this callback function, and this is the callback function, rx callback function, right? So I will use this function. Here what I'm doing, I will simply copy this as it is, right? So that you can easily understand the advantage of this HL library, Hall library. So no need to write everything, no need to remember everything. You can simply call this, you can simply take this from within the code, right? And this is what the advantage of this all library. Okay, so now I'm just writing this callback function over here. Now first of all, as interrupt will receive, automatically this function will execute, this function will call. So first of all, we have to check whether the interrupt is come from the UART5 or not. And for that, you have to simply write our handler of the UART, which is H UART5, right? And if this condition will satisfied, it means that interrupt comes from the UART5 only, right? And now, as I already declared that our communication will be interrupt based, and for single byte this interrupt will call, we have to store our whole string, whole message into one array. And for that, let us declare one array rx buffer. So this will be the array. For now I'm giving size of 20, so let us assume that our message will not more than this 20. And one index also we need, because we have to store this one by one. Okay, so we have to have some index, and index should start from 0, right? So now I'm going to store our message, our single byte message, into rx buffer. Okay, and our index is this buffer index, and our message will be in UART character, right? Single byte each time. And now each time this message will continuously call this interrupt, because we have some message like hello world. So first for h this interrupt will execute. So h will store in first position, or you can say 0th position. Then again for e this function will call. So I have to simply increment this by 1, okay, continuously. And to make it reliable and valid string, I have to have some null character at the end. And for that, I'm just writing buffer index is equal to null character. Now what happen, each time this function will call, this index will change, okay, increment by 1. And finally when our string will terminate, or our message will end, so at last character it will add this null character, right? So it will make this string valid string, okay, simply. And now what I will do, we are assuming that in our message from GSM we have some end character, right, new line character. So I am just comparing now our string, whatever our string is there, right? And I'm comparing this using this library str. So this basically compare some input message with the whole string. So our string is rx buffer, right? And I'm searching for new line character, right? Slash r slash n. And if this will not equal to null, it means that this character is present now. So we can identify that, okay, this is the end of the message, right? And now we will do something. So now when we found that the message is now finished, so I'm just, let us uh, use one flag for indication, right? That okay, the message is now finished. So this, let us give name SMS REC, SMS receive. And initially value will be 0, okay. And whenever we found that okay, now complete message is received, we will simply make it 1. And now using this flag, by comparing this value, we will take decision, we will extract the information of the message, and we will take the decision, right? So now for that, in while one, I'm calling one function called process SMS. and in this function we will going to check that flag. Okay, and let us add some small delay. Okay, and now within this process SMS I will going to check something. Okay, now one more thing, after first time when this function will call, we have to have this uh, interrupt enable, right? Because this is outside of while loop. So after first character received, interrupt will not enable. I have to simply call this function continuously. Okay, after this whole logic I have to call this function. So next time whenever interrupt will next time whenever some activity detected on the UART5, it should convert into interrupt calling, right? That's why I have to write it after this. For each character it will append with this message. It will check whether the string is end or not, then again it will enable the interrupt. Again next time next character come, again this process continue until whole message will received in this buffer, rx buffer, right? And now let us start this process SMS function. So here void, now we have to simply check this flag, right? So if this flag is not zero, let us do some exercise. So now user can simply say that something is there, some message is received, and let us indicate first of all on UART3. Okay, now we have the message. Okay, we have the message. So this message will print on our terminal. Okay, so user can understand, and let us also print the message also, right? Whatever message user send, let us just print the message, and our message will be in rx buffer. So just I'm printing this as it is without doing anything. Now next part is we will simply check if str rx buffer contain on, means if rf buffer is having this on word, then do something. If is not contain on, but instead of on, let us our string contain off, then do something. And finally else, do nothing, simply print that we have not received valid message. Message is invalid. Okay, /n. Now if message is valid and if message contain on, so let us simply print led on. Led on. If message is valid and message contain off, print led off. Now with this we also want to turn on or turn off the led, right? So for that we have already use pb7 led, right? I think, and I have this function also with me. I'm just simply using this function over here. Yes, and if led is on, set this led. If led is off, reset this led. So this is what all about the code. Now let us debug this and check if any error is there or not. So basically what we are doing, we are simply enabling the interrupt on UART5. Now whenever GSM will receive any SMS, it will forward this SMS to UART5. UART5 is based on interrupt. It will simply receive each character. It will append that character in our on RX buffer, and after that we are just checking what is the content of RX buffer. If it has on, it will simply on the LED. If it contain off, it will simply off the LED. One more thing, we have to make this zero, right? Because after each message, after each on or off event, if this will remain on continuously, so it will be not efficient part, right? So we have to make this zero, so that next time whenever message will receive, again it will come in this process SMS function, again it will check for this logic, otherwise it will simply wait over here, right, within the while one part. So let us make it zero. After this, right, make it zero, simple, right. Let us release the target, load it on the board, and check for the next part. So now its hex file is generated. Now I'm loading it on the board. So now upload is done. Now here you can see the hardware. Again I'm loading the file so that you can understand. Using by observing this LED, you can see is changing color, indicate that something is uploading. Now program is loaded on the board. And now let us open this. This is with connected with this 4 port number. What it is same. Let us reset this board, and you can see this GSM configuration done, received. So now this module is configured with this receive SMS functionality, and now I will simply send the message, and we will going to observe this LED. I think there was some issue in the code, so I have just added following thing. First thing is we have to clear the RX buffer. So after this SMS REC is equal to 0, we have to clear the RX buffer so that buffer can receive the next message from 0th position. And also I have added this part. So in this part, what we are just trying to check that whether the buffer index is less than the buffer size. Okay, because the buffer size is 20. So if the buffer index is more than this, so it means it is overflow, right? So we have to check this condition. So if the buffer index is less than RX buffer, then and then do this, else clear the RX buffer, set buffer index to 0, and just print this message. Okay, so this is what I changed. And one more thing I would like to do, that in while one, you can see we have this process SMS and delay function, but the I found one issue, that this interrupt is not set or enabled after this. So just let us put this in while one loop. Okay, so continuously we have this interrupt enable. Okay, and let us put delay is equal to 500, because we know that our whatever our message is there, like let's say we I'm sending hello, so between HELLO the delay would be less than 500. Okay, so let us set this you are receive it with one character with 500 delay, right? So whenever one message completed, again it will set this interrupt again. Okay, means it will enable the interrupt, and next time it will execute this callback function. Okay, so after doing these changes, let us again release the target. And one more thing I would like to do, that for the safety purpose I am removing this part, okay, because this may reveal the mobile number. I'm just commenting out this part. Okay, and now I'm again releasing the target, and I will put this code in description. Okay, so you will get it. Now upload this. And check this. Now we have the message GSM configuration done, and now I'm sending on message, and you can see we have LED on. Now I'm sending again off message. I can show you over here. You can see LED is off now. Again I'm sending on message, and again you can see LED on. So this is how you can receive the message. I know this code is a little bit complex, but you can check it one by one, instruction by instruction, so you can easily get the idea what is happening. And you can also print in between. So I'm using send command 3 button to printing the message, so you can this for troubleshooting as well. So this is what for this video. Next video we will send the SMS based on some event using same configuration, tank setup. Till then, if you like my work, please like my YouTube video, subscribe my channel, share it with your friends. Till then, bye bye. Thank you very much.